back. Today we're going to take a look at rationalizing the denominator using something called the conjugate. All right, we have a binomial in the denominator of this fraction, 5 minus square root of 3. Now, if we just had square root of 3, then to rationalize the denominator, we'd multiply top and bottom by the square root of 3, and root 3 times root 3 would just be 3. But we have this pesky 5 minus hanging around, so that won't work. So when you have a binomial with a root instead of a monomial with a root, you are going to multiply top and bottom by something called the conjugate. Now you'll notice the 5 is the same, the root 3 is the same, and what has changed is the sign. This was a minus, so the conjugate will be a plus. And if this had been a plus, then the conjugate would be a minus. And as you know, we can do the same thing to the top and the bottom of a fraction, and the fraction will remain the same. We're just changing its form. Now, here's the magic, and here's why this process works. Let's go ahead and FOIL through our denominator. Firsts, outsides, insides, lasts, simplify. Notice the two inside terms cancel each other out. Plus 5 root 3 minus 5 root 3 is just 0. And that will be the case every time. And that's why we multiply by the conjugate. It makes the two terms that contain the root cancel each other out. So now I just have numbers to simplify, and that's the new denominator, no more roots. Now I just have to distribute through my numerator, and I get, and my final step is that I see that each of my terms, 36 and 22, contain something common. They each contain a 2, and so I can divide that out of each term. And my final answer is, and that's its most simplified form after we have rationalized our denominator.